Hello everyone, in this video I am going to teach you how to find the domain of a rational function that has a square root in the numerator and in the denominator. I also have videos in my YouTube channel that talks about that will teach you how to find the domain of specific functions, so please look for that in my YouTube channel. So for this lesson, let's begin with the first example. We have here the function of square root of x plus 4 over square root of 2x minus x, 2 minus x rather. So there are two things we need to consider here, our numerator and the denominator. So what we will do is find the domain of the numerator, and then find the domain of the denominator, then find the intersection of those two domains. Okay, let's begin with the first domain, which is the domain of x plus 4. So this is how we set it up. X plus 4 is greater than or equal to 0, which means it cannot be a negative number. X plus 4 cannot be a negative number. It can be 0 or positive. So subtract 4 on both sides. This will be x is greater than or equal to negative 4. Okay? And then for the denominator, we have 2 minus x. It should be greater than 0 only. It cannot be equal to 0. So divided by, or subtract 2 on both sides. This will be negative x is greater than negative 2. And then let's divide negative 1 on both sides because that x should be positive. And when we divide the negative number in an inequality, that will switch from greater than to less than. If it's less than, it will become greater than. Okay, so please remember that. Now it's it will be easy for us to understand or to find out the domain or the intersection of those two if we have a graphical representation. So let's locate those two domain here. We have x is greater than or equal to negative 4. So here is our negative 4, right? It says greater than or equal to. So here is the greater than or equal to. And then for the less than positive 2, which means this is the graphical representation of that. Our intersection is this, which means the domain is from negative 4 to positive 2. Okay, using the interval notation. Okay, and I put the inclusive, it's a bracket because negative 4 is part of the domain, and then with number 2 I use a closing parenthesis because positive 2 is not included in the domain. Let's go to the next example. We have x squared plus 4. So x squared plus 4 is greater than or equal to 0. We subtract 4 on both sides. Therefore, x squared is greater than or equal to negative 4. And then we simplify the square root of both sides. And of course, we already know the square root of negative 4 is an imaginary number. It's not a real number. So which means that the domain of our numerator will just be from negative infinity to positive infinity. Okay, we're talking about the domain of the numerator. What about the denominator? So 10 minus 2x is greater than 0. We subtract 10 on both sides. This will be negative 2x is greater than negative 10 divided by negative 2. And of course, when we divide or multiply a negative number in an inequality, that symbol will change. So here, the domain or our domain will be x is less than 5. Okay, so let's have a graphical representation of that. The first one is from negative infinity to positive infinity. Here is the graphical representation of that, obviously. And then for all the numbers from negative infinity to positive 5, 1, 2, 3, 4, 5. Again, that 5 is not included, so here is the graphical representation of that. And obviously here is the intersection, which means it's from negative infinity to 5. Okay, let's go to the third and last example. So let's have x squared minus 9 is greater than or equal to 0. We add 9 on both sides. This will be x squared is greater than or equal to 9. And of course, we need to find the square root of that. So x is greater than or equal to positive negative 3. In our denominator, or numerator rather, we have negative 2x squared plus 32 is greater than 0. So we subtract 32 on both sides. This will be negative 2x squared is greater than negative 32. And then divided by negative 2, divided by negative 2. X squared is, that will switch, that will change, 16. And then we need to find the square root of both sides. Therefore, x is less than positive negative 4. Okay? So let's find the intersection of those two. Again, it will help us if we have a graphical representation of that. So let's locate 1, 2, 3, 4. Here's 3 and 4. 1, 2, 3, 4. Here's negative 4 and negative 3. So what do you mean by greater than positive 3, negative 3? So basically, the meaning of that is we will start here from positive 3 to positive infinity, and then from negative 3 to negative infinity. So that's how that's the graphical representation of x is greater than or equal to positive 3. Okay, so if you're not familiar with that, let me just explain that further. Okay, I will draw again a graphical representation of this domain. So we have 1, 2, 3. Okay, just in case you're still not watching my video about this particular topic, I think it's about the square root function. I have a problem like this in one of my videos, so please check that out. Okay, so here, so the story behind this is we need to find the region that will satisfy the inequality there in our numerator, that square root of x squared minus 9, right? So if we will replace that x by 0, right? So 0 squared is 0 minus 9 is negative 9. So we do not want that. So that's why we have this graphical representation. Okay? So you know where I'm going. So which means that x is less than positive negative 4. The graphical representation of that is this. From negative 4 to positive 4. There you go. So where is the intersection? So the intersection is right here. There. There is the intersection. And also here. Now, how are we going to convert that into interval notation? So let's begin with negative 4. Okay. Open parenthesis up to negative 3. And then we will close that using a bracket union of 3 to 4. There you go. So that's how we convert that into interval notation. That's the graphical representation. Here is the further explanation of the greater than symbol. So if it's a greater than symbol, it will begin from negative infinity until that first number, and then the second number until positive infinity. If we're dealing with the less than symbol, it's going to be from the first number and then up to the other number. Okay? So that's it for finding the square root of a rational function that has a square root in both the numerator and the denominator. So thank you for watching. I hope you learned something from this lesson. Have a wonderful day.